This problem is the summation of indexed data from the ALEKS statistics course. And first of all, we notice here that we have this expression. And one of my students came in recently and said, man, I can't work this problem because it looks like Chinese. And so I said, well, don't worry, it's not Chinese, it's only Greek. And she said, wow, that really helps, Professor. So let's see if we can go through and see what's going on here. First of all, take a quick look at my notes and notice here that we have the symbol sigma. This is a capital Greek letter, sigma, which is very much like our English letter S, which is the first letter of the word summation, which basically means to add up a list of numbers. So basically this symbol here is really no more intimidating than a plus sign. It simply means to add up a list of numbers. Now the good news is that you don't have to do any of this addition by hand, that you can do it all with the ALEKS calculator. And here is what you do step by step. First of all, you can click and drag those numbers directly into the ALEKS calculator and then simply press the summation of X button, and that will add up that list. So let's go back and take a look at the problem that we have here. And let's play with this for just a second. Get your ALEKS calculator up here. Just click and drag this list of numbers. And then when you hit this button right here, the summation of X button, what that's going to do is to add that list up for you instantly. So that takes care of a lot of it. Now in the problem that we have here, notice that we need this sum, but that's not all that we need. We need 38 minus that sum. Now, there's a couple of ways we could handle that, but here's an easy way. Just simply go over here and store this value. We can clear the calculator now and we can put 38 minus this summation, which of course the answer to that is stored. So we simply click recall and equals. Our answer is negative 108. Let's check that and see if that would make ALEKS happy. And it does. So we need now to look at the fact that there are several of these types of problems. So let's find that there are 4 variations of those. And what I've done is I've to summarize those 4 variations in my notes. So let's kind of once again take a quick look at those and see what we have. Now what we've seen in the first example was one like this. We have some constant plus maybe some number multiplied by the summation. And so as before, we simply grab those numbers in the ALEKS calculator, we hit the sum button, and then we may have to multiply. In this last example, we didn't. Essentially multiplied by 1 and then just added or subtracted a particular number. So then you're done. They have some other variations, and what we may end up having to do here is to look at those problems that they send us, compare that to these different variations, and then select one of those and then follow through with that. So let me show you another example of that may show up in ALEKS. Let's get another problem up here. Okay, notice this type now. We have the summation, and then we have a parentheses, which is going to be your x sub I minus some number. Now, obviously, if we were doing this according to Hoyle, we would simply take each of these numbers, 42 minus 23, get the answer to that, and then we would add. Then we would take our next number, 40 minus 23, and then we would add. And we would continue to do that throughout the entire list. But the good news is I have done some of the algebra for you, and what I've done here is simplified that quite a bit. So notice here that in our second example we have that very problem. We have the summation, and in parentheses then we have this x sub I plus some number. Now there is an entire algebra that goes with summation notation, and whenever I want to show that to my students and show them step by step how to do that, they say, well, that's really nice and everything, but could you just show me how to get to the answer? And so, okay, here's what you do. In this case, you will simply go ahead as before and add up your numbers. Then what you will do is you will add on to that n, which is this number at the top of the summation sign multiplied by this number, because what this number here is basically this a is being added n times. So if you add a number n times, you're really multiplying n times a and then adding that product. So let's take a look at that example here that we have, and let's try to work that. So notice here in this case we have the x sub I, but it's negative 23, or you can think of that as that we're adding negative 23 to that. So according to our formula here, simply grab the ALEKS calculator, grab all of our numbers, add them up as before. Now we will have to subtract this time. So we'll go up here and subtract our 13 times 23. So 13 times 23, and this then will crank the whole thing without any in-between steps because ALEKS knows the order of operations. The answer is, amazingly, -1. Let's check that and see if ALEKS likes it. And incredibly, they do. And so what we need to do next here is to find yet a third type of. Okay, in our third example here, notice that we have -22 times each x sub I. So once again, if we were going through this the long way, we would take -22, multiply by -38, then add. Then we would take -22 times 44, and then we would add, and we would repeat that through the entire list 10 times. Again, we're not going to do that. We're going to take the shortcut. Once again, consult my notes here, and notice that if you have some number, this a is a constant, which is multiplied times each of your x's, it is possible to simply take that a and factor it out. We can essentially pull it across the summation sign so that we simply take that constant, which was multiplied times each of the x's, and just multiply that times the total sum of the x's. So what we'll simply do then is go back to our example. We will grab our calculator. What we will do then is to pull these numbers in and add them up as before, then simply multiply the answer one time by the -22. And so the answer that we get, 2,750, and let's put that in there and see if we have made ALEKS happy. And remarkably, we have. Let's look at the next example. Now in our fourth and final example, we have the summation of x sub I, and each of those x sub i's is divided by 12. Now we can use the very same trick that we did the last time when we were dealing with a constant that's multiplied times each of our x's, because in this case we can simply think of that same situation being in effect, except we're multiplying by 1/12. So basically the plan is add up all the x's, get the answer, and lastly divide it by 12. So that will handle this. Once again, grab for the ALEKS calculator. Go in here, get your numbers, pull them in, add them up, divide by 12, and the answer is a decimal. Notice that they want us to round to at least 2 decimal places. So at the second decimal place we have a 3, the next digit's a 3, and so -6.33 should make ALEKS happy. Let's check and see if it does. And yes, we have now mastered the summation of indexed data in ALEKS statistics.